Hello students, today we will talk about total internal reflection. So let's start with the word reflection, and we know that bouncing back of light from a plain polished surface is known as reflection. So this ray when strikes a plain polished surface, this point is known as point of incidence, and if we will draw a normal here, which is a perpendicular line which makes 90-degree angle with the surface, and when the incident ray after striking the surface comes back into the same medium, this phenomena is known as reflection. This angle between incident ray and normal is considered as angle of incidence, and angle between normal and reflected ray, this is reflected ray, considered as angle of reflection. And angle I is always is equal to angle R in case of reflection. Now, after reflection, if we'll talk about refraction, refraction is bending of light when it travels from one medium to another medium. Suppose this is the light, this is the line which separates two mediums. So suppose medium above this line is air and below this line is water. So as we know that index of refraction or refractive index is different for different mediums, and index of refraction for water mu W is always greater than index of refraction for air, or we can say water is denser as compared to air. So optical density of water is more as compared to air. So what happens is, suppose this is incident ray and this is point of incidence, and we will draw a normal here. So what happens is, in this case light ray is entering from a rarer medium to denser medium because water is denser as compared to air. So if light enters from rarer medium to denser medium, it bends towards the normal, and suppose this is angle I, angle of incidence, this is angle R, angle of refraction, this is incident ray, this is refracted ray. In this case, angle I would be greater than angle R, or we can say angle R would be less than angle I, lesser than angle I, right? So this happens when light ray enters from rarer medium to denser medium, and the reason behind this bending of light is the change in speed of light. So when light enters from a rarer medium to a denser medium, the speed of light reduces. Like speed of light in air is 3 times 10 to the power 8 meters per second. In water, it's 2 times 10 to the power 8 meters per second. It's lesser than the speed of light in air. Similarly, if we will consider water and here glass. So glass is so glass is denser than water. Like water was denser than air, density of glass is more than the density of water, and refractive index is also greater than the refractive index of water. So what happens is, here this is rarer medium and this is denser medium, and suppose light is coming from denser medium. Here this will be incident ray, and we will draw a normal here. This is point of incidence. So what will happen after refraction? Light ray will enter into the another medium. Like in reflection, light ray comes back into the same medium, but in refraction, light ray goes into the light ray enters into the another medium whose optical density is different, either lesser or more than the previous medium. So here the case is light rays entering from denser medium to rarer medium, and in this case speed of light increases and it bends away from the normal. So if this is I and this is R, angle R would be greater than angle I. So this was about reflection and refraction. After this, we can try to understand the concept of total internal reflection. And there are two conditions for total internal reflection, two necessary conditions. First is light ray should enter from denser medium to rarer medium. So light ray should travel in such a way that it will strike, it will go from denser to rarer. So this is the first condition. And second condition is that angle of incidence, which is angle I, should be greater than critical angle theta c. Now what is critical angle? So to understand the concept of critical angle, we will take two mediums, glass and let's take air here, air and glass here. Right? So air is rarer and glass is denser. Rare, dense. Now, because light ray should travel from denser medium to rarer medium. So we'll start from here because glass is denser. This is incident light ray. This is normal. So what will happen? Angle I, and because it is traveling from denser to rarer, it will bend away from the normal. Now, if we will increase angle of incidence will be this much. Angle of refraction will also increase. If we'll keep on increasing angle of incidence, angle of refraction will also keep on increasing. At a particular value of angle of incidence, suppose this is the incident ray at which what will happen? The refracted ray will follow this path, or it will go, or it will make 90-degree angle with the normal. So at a particular value of angle of incidence, this value I, which will be equal to theta c, critical angle. So what is critical angle? Critical angle is nothing but angle of incidence at which refracted ray makes 90-degree angle with the normal, or it goes perpendicularly with the normal. So when refracted ray will follow this path, at that particular value of angle of incidence, we will say it is equal to critical angle. So we will consider this angle of incidence as critical angle. Now, if we will further increase the value of I beyond critical angle. So what is the condition? If angle I is greater than theta c. So what happens if angle I is equal to theta c? If angle I is equal to theta c, refracted ray makes 90-degree angle with the normal and it goes perpendicularly with the normal. And if we further increase the value of angle I beyond theta c or critical angle, light ray will not refract, it will not go into another medium, but it will come back into the same medium. And when light ray comes back into the same medium, we use term reflection, not refraction. So this particular case is considered as total internal reflection when light ray comes back into the same medium, and it will satisfy the properties of reflection. So angle I will be equal to angle R in this case. And the best application of total internal reflection is propagation of light inside an optical fiber. Optical fibers which are made up of glass, thin glass or plastic. Like suppose we have two hollow pipes and we will insert one into another, two hollow pipes of different diameters. So the pipe which has lesser diameter we will insert inside another pipe, and we can use optical fibers at the place of copper cables to send signals from one place to another, and they send signals with minimum loss. So when light enters inside the optical fiber, what happens is this optical fiber we construct in such a way that the refractive index of this medium is always greater than the refractive index of this medium. This is considered as core, this is considered as cladding, and refractive index, or we can say density, optical density of this region core is always more than the refractive index of cladding. So here when they strike the interface, this will be denser, this will be rarer, so it will satisfy the property that light ray should travel from denser to rarer medium, and it will come back into the same medium, and then it will strike again here, and then it will go back again. This way light propagates inside optical fiber, and finally it comes out with minimum loss and maximum energy. So this is how we can use optical fibers to transfer signal from one place to another, and light travels inside optical fibers based on the concept of total internal reflection. There are some other uses and applications of total internal reflection, but I think this one is enough and it will solve the purpose. This was all about total internal reflection. I hope you like it. Thank you. Bye bye.